Morning.
My name is Rashmi Uday Kumar. I'm an assistant registrar for communications and PR and students affairs at IIT Madras. On behalf of the institute, I welcome you all to a very special knowledge session we have organized today on artificial intelligence, which will be conducted by my esteemed colleague and foremost expert in AI, Professor Ravindran. It is my genuine pleasure to introduce Professor Ravindran, who has more than 3 decades of experience working in reinforcement learning, and his research interests span responsible AI, learning, learning on graphs, and deep RL. He is the founding head of the Vadhani School of Data Science and AI, Robert Bosch Center for Data Science and AI, and the Center for Responsible AI at IIT Madras. He has held visiting positions in several national and international institutions of repute, including IISc Bangalore, University of Technology Sydney, and Google Research. Professor Ravindran has chaired the National Task Force on AI and Cybersecurity and was a member of the Government of India's Task Force on Defense Applications of AI. He is a member of the Government of India's Advisory Group on AI for India-specific regulatory AI framework and the Government of India's Committee on Matters related to issues of deepfakes. He is also a member of the AI Advisory Council of the AI for India's 2030 initiative of the World Economic Forum. He represents India on the expert advisory panel to the UK's State of the Science Report on Advanced AI Safety. He serves on the Global Commission on the Responsible Use of AI in Military as well. Professor Ravindran will be also discussing some of the shortcomings of current AI technology. The workshop will be completely non-technical, and it does not really requires any prior background in the domain. At the end of the session, we will open the floor for some questions and answers. I request all of you to kindly post your queries in the chat window, and at the end of the session, I would request Professor to take them up. Please also mention your name and organization when you are posting a question. So we'll flag those to the professor once he finishes the talk. So I now invite Professor Ravindran to take it ahead. Please, sir. Thank you.
So thank you, Ms. Rishmi, for the kind introduction. And so thank you everyone for joining today's session. So before I start off, so let me set the expectation very clearly. So this is going to be like a very basic introduction to what is AI, right? So it is not going to be a technical introduction, and it is not going to be very deep. I'm not going to talk about the newspaper stories that appeared yesterday or the latest release from OpenAI or anything. I noticed that I recognize several names who have joined. I mean, amazing, fantastic science reporters who actually joined the call today, and so a lot of what I say would probably be familiar to you, right? So with that caveat, so let me start. So some of the advanced questions that you have, we do have a lot of time set aside for interaction, right? So I'm happy to take slightly deeper questions. But the goal of today's interaction is to, for people who are writing about related concepts and looking at the impact of AI on the society and want to understand what is this thing called AI. So let's again start off with one thing. So this was not the start of AI. Right? So today we launched ChatGPT. Try talking with it here. This happened in December 1st, 2022. A lot of people think the AI revolution started in 2022, right? So that's not true, right? So AI as a discipline, right, is not new. Right? Some people argue that it started when Alan Turing asked the question, "Can machines think?" Right? I proposed to consider the question, "Can machines think?" And this was back in 1950, and he came up with what he called then the imitation game, and what we all know today as a Turing test, right? To understand, okay, if a machine can imitate a human, so that another human cannot tell it apart, right, from a human or a machine, then you'd say that machine is intelligent. Okay, that's a very functional definition of what intelligence is. Doesn't really get into how intelligence arises and so on and so forth. And in fact, most modern AI systems can comfortably beat what is called what some version of the Turing test today, but that doesn't make them truly intelligent, right? And the term AI itself was coined in 1956 at now what is now known as the Dartmouth Summer Research Project or Dartmouth Conference on AI. So where some of the top people in artificial intelligence at that time met and debated about what does it mean for a machine to be intelligent, right? So and then they came up with this idea of artificial intelligence and talked about various things that can be set up, right? And it's not that AI, as a discipline has existed for a long time. It's actually AI success is also not new, right? So here are some examples that I'm putting up for you. Let me see if I can get a laser pointer here. Yeah, great. So this is Arthur Samuels, and Samuels wrote a checker playing program. The amazing thing about the checker playing program is it learned completely from scratch. In fact, nobody even told it, what is the goal of checkers, right? It learned everything from some kind of a trial and error mechanism, and he was able to demonstrate on live television back in 1956, right? The how like in this checker playing program, right? And then in 1966, right? There is this chatbot called Eliza, right? And so it was actually available on the market for people to buy and play around with and so on and so forth, right? And of course, some of you might remember even in the Indian market, there were things like fussy control washing machines back in the 90s, early 90s, right? And so all of these are examples of AI systems that have been put into practice, and some which have actually gone into market, right? And if you think Eliza is something very old school chatbot, look at the kind of conversations that Eliza could hold. Right? Is something troubling you? Men are all alike, right? Go so on and so forth, right? So look at that. It's a fairly nuanced conversation, and it was meant to be a psychotherapist, right? And it managed to do so well that people were actually trying to build products out of it, right? So this was one of the earliest success of what were called expert systems back then, and the expert systems are all the rage in the 60s and even up to like even the 80s, right? People are using expert system, and even today you would find in some of the industrial settings, you would find a lot of expert systems that are being deployed, right? So it's not that no technology is new and success is new. Unfortunately, AI hype is also not new, right? So here is a headline. So the Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. And when did this appear? This is an article from 1958. It's not like it's like maybe a couple of years after the word AI was coined, right? So you already so after the word AI was coined, so we actually started having hype that talks about AI that can be conscious of its existence. Hmm? Sorry. And so moving on, so here is a timeline that I created of AI, right? So the whole term got coined in the 50s, and Alan Turing started thinking about it. In the 60s, you could see the first wave of AI with products like Eliza and the checkers playing program and things like that, and then all the hype that came with it, right? So already people are talking about this kind of models. And then when kind of in the late 60s, right, there's kind of a disillusionment set in because AI was making significantly more claims, or the people were making significantly more claims on behalf of AI than AI was able to deliver. And so we got into what was called as the first AI winter. Right? This lasted about a decade. And then in the mid 80s, and Jeff Hinton, who's recently in the news for his Nobel, kind of led the revival of this AI. Of course, there are a lot of controversy about whether Hinton really was the person behind it and things like that. But I as a researcher, right? So we would the first thing I would probably cite is Hinton's work. And so Hinton kind of led the revival, and then you had a lot of work that was coming in, and in the mid 90s to 2000, right? So you started getting industry adoption of standardized AI tools, right? There were MATLAB had AI toolkits that people could use and so on and so forth. There was a lot of adoption of AI in the industry, but then again, what happened was the artificial neural networks of that age, right? Promised a lot and did not deliver, right? They were not able to standardize things to a level that people could use it, reliably, and therefore kind of a second winter set in. But now we are in the third wave, right? So this has been, kind of catalyzed by these recent advances in deep learning. I'll talk a little bit about what these are, right? But more importantly, you started seeing the emergence of AI first companies. I mean, some of the earlier breakthroughs were coming from, people like IBM, right, who basically had a whole other operation, right? They were not an AI company, so IBM was actually working on AI, but their main business was something else. And then later, you had people like Google come in. But then, now in the third wave, you see companies like DeepMind and OpenAI, which basically do AI, right? I mean, they don't have another product, right? That they are trying to use AI to improve. And what we see today is something which I don't think has occurred in the history earlier, where instead of using AI to improve on a product, right, whether it is ELIZA or some of the industrial applications, instead of using AI to improve on a product, now AI itself is a product, right? So if you think about what OpenAI is doing, they're basically selling access to an AI. Or if you think about what Gemini is doing, it's just selling access to an AI, right? So it's not necessarily a service behind the AI, right? And of course, the latest swing of hype is now that we are beginning to win Nobel Prizes for contributions to AI, and we don't know where this hype is going to go. But I feel that there's a fundamental difference now because of the maturity of the technology and how widely it has been adopted, right? So you can see here, so not only are we talking about simple things like social media, making it easier for us to interact on social media and recommendation systems and all these purchases, voice bots and things like that, but also more important domains like healthcare and legal domain and finance and so on. So for the AI is affecting every aspect. So I think because of this more broader adoption of AI into all fields, I do not think that we will get into another AI winter anytime soon. And so before we proceed further, right, I just want to emphasize on something here, right? So we've seen that AI is old, right? AI has been around forever, but we should not be talking about really about AI as a single technology, right? So let me give you a few examples, right? So we already talked about ELIZA, right? So we said it's an expert system, but it was actually based on a lot of rules, right? So the reason it was called an expert system was they had taken feedback, input from an expert, right, human expert, and kind of written out rules that capture all the knowledge that the human expert had. And of course, it was not a trivial process, but still. It was not something that which learned or adapted, but it was more of a rule-based system. But that was also called AI, and it's still certainly AI. But like I said, it's not a single tech. Of course, there is this Deep Blue, which basically beat Kasparov. If people recall, this was back in the 90s, and the way Deep Blue operated was basically by doing a large-scale search through all possible moves that you could make. Right, it required significant amounts of compute, but and also it used a little bit of other knowledge, but it was primarily a search-based technology that managed to play chess at really competent levels, right? And again, it's very different from the kind of technology that was used to build ELIZA, right? And then, of course, there is the IBM's Watson engine, which did very well in the Jeopardy quiz game, right? So I'm pretty sure many of you remember this, and so it was able to beat like the many time human champions and so on and so forth in a face-off. And the way it worked, right, was essentially lot of domain knowledge was encoded as logical statements in somewhere in the computer. Let's not get into the details of it, but it just used all the logical statements that it had and tried to do reasoning on it, just like humans would do. If A is true and then B is true, and then maybe C is true. So these kinds of reasoning that it was doing on this huge knowledge base that it had, and it was able to do a great job. Huh? Uh, so the other thing, so I mean, I was giving you this example of people, tagging photos in social media and so on and so forth. This belongs to another sub field of AI called computer vision, and this was one of the early successes of what's called deep learning, right? So it's very different from how the three models that I already spoke to you about operated, right? So this is deep learning. And then, of course, you have AI that's being used to improve search itself, and AI that is used to, improve the rankings that you see. I'm sorry, improve the advertisements that you see on a search page and so on and so forth. All of these, there is some AI that is running in the back of it. All of these are primarily learning systems, right? But they have very different kind of learning than you see in how people do tagging. So, and again, a different technology that comes to play, right? And of course, there was this huge hoopla, I think it's 2014, about computers playing Go, the game Go very well. And DeepMind basically, made its name by building an AI that will play Go very well, right? And this was, a technology called reinforcement learning combined with deep learning, which people call deep reinforcement learning now, and that managed to beat the human at Go, right? As is a different kind of technology. I mean, of course, you could use each technology for play. You can use reinforcement learning to play chess, right? So, but that's the point here I'm making is AI is like this, literally like a grab bag, right? It's a mix of all of these technologies in there, and you keep calling it AI. Of course, some of you might remember this news about AlphaFold, where DeepMind came up with a tool that was able to predict protein structures, right, from sequences, and they managed to create this protein structure database. And the thinking is that this has significantly changed this space of everything, right, including personalized drug design and so on and so forth in the biospace, right? And but here we used a hybrid approach. It used some amount of deep reinforcement learning, but also used a lot of search techniques, right? Like we talked about in the deep blue setting, right? So you can see that AI itself, right? It's not a single technology. It's going to be a mix of different kinds of technologies, right? So now that we have given you a little bit of a history and the context, I want to talk a little bit about this idea called deep learning, because in some sense, the latest revival in interest of people in AI started with the successes people saw in deep learning, right? So basically, there were all these problems that were considered easy for humans, but hard for AI. And one of the primary ones was computer vision, right? Humans were able to tell you, if you show a picture, right, they were able to tell you what is there in the picture very easily. But AI systems were having a lot of trouble with it, right? So they were able to perform, as you can see, this is back in 2010, they were getting an error rate of about 28%, right? More than 1 in 4 pictures they got wrong, right? While the humans were getting about error rate of 5%, right, which is it's fairly good, right? So we basically have only about 1 in 20 wrong, right? So that's the gap that was there. And then this technology of deep learning came, and we were able to get better than human error rates, right? So one of the early successes, this is on the computer vision task, this is on the speech recognition task, this is what is enabling all your advances in Alexa and OK Google and all that, right? So of course now been a significant change in the technology, but just giving you a little bit of an historic perspective. So some of this lecture, right, today, right, is be really like a lecture, right? So I'm going to take you back to school a little bit. So here is the first example of that, right? So let's say what is first before we getting into deep learning, let me give you one couple of slides on what is machine learning, right? So the idea here is to learn decision rules from examples. That's what machine learning is. That's what deep learning also does. So what you do is you give a lot of these kinds of examples. So all the pictures in the first row, I would say are airplanes. All the pictures in the second row, I would say are automobiles. All the pictures in the third row, I would say are birds, right? And now the goal is to learn a decision rule. So what do I mean by this? Let's take a simpler example. So here are some customers in a database where I'm kind of just plotting their age and income. And I also, okay, I hope you can see there are two colors on the screen. I'm also telling you that some of them are likely to buy a computer. The brown ones will buy a computer, and the red ones will not buy a computer. Okay. Now, what I want you to do is to learn a rule that will tell me if a new customer comes into the shop, right? Will he buy a computer or not? So this is the age and income of the person. Is he likely to buy a computer or not? There are many ways in which you can try to build a decision rule, and this is one possible decision rule, right? Anybody to the right of this line is likely to buy a computer. Anybody to the left of this line is likely to not buy a computer. So the gray person, right, the new person who came in is likely to not buy a computer according to this decision rule, right? The very simplified example, obviously, I mean, I can't plot the big pictures that we were talking about, but the idea behind deep learning is to use more and more complex functions, right? So here I was just drawing a simple quadratic function, right? So most of you know, like it's literally like ax squared plus bx plus c kind of a curve, right? But we are talking now about much more complicated functions that were actually originally inspired by the brain, right? How the brain encodes information. And therefore people started calling it neural network, and then the more layers you stack in, right, it became deeper and deeper, right? So the idea behind this is simple. Let's not, I'm just going to show pictures, right? No equations. So the idea is something like this, right? So the first layer, right, is kind of learning to respond to just colors and texture changes and so on and so forth. And the second layer, these are all automatically being learned. I'm not pre-programming what you should be looking for in each of these layers. All I'm telling it is, okay, here is an input, and this is the output that you have to come up with, right? So all I'm telling you is that, right? Based on that, the deep architecture actually automatically learns these kinds of features. Then the second layer learns corners, edge, and edge and color, matching and things like this. You can see some of the examples here. And then the third layer starts learning more about these kinds of similar textures, right? So more repeated patterns and things. And the fourth layer starts learning object parts. And in this particular example, we only had 5 layers. So the fifth layer is actually starting to learn about the whole object, right? So look at this. This particular thing is learned about dogs, right? And this is learned about flowers and so on and so forth. Each of these layers kind of learn more and more successively complex features. And basically, what happens is when you start putting them together, as you can see here, the number of layers keeps increasing. So AlexNet came in 2014, and it caused a huge improvement in performance, right? So the previous year, the best performing model had about 12% error, while AlexNet reduced it to about uh, oh no, sorry, AlexNet reduced it to about 16% error. Okay. So that was the big jump. So the previous year, the model was about 26%. AlexNet reduced it to 16%. That was the huge jump. And people started to sit up and take notice when an AI model was able to do so much better than the previous years. And then you can see that every succeeding year, and we kept reducing it until we hit with ResNet, we hit 3.6%. These are all different architectures. And of course, apart from the number of layers, there are other things that differentiate these architectures as well. But you can see that people just were going overboard with deep learning, and they were trying to talk about many layers, right? And this trend is kind of saturated now. People don't even talk about layers anymore, right? So each layer has a certain number of parameters that you are using to model it, right? So quickly, so each of these connections from one layer to the other, right? So these all have some some specific parameter associated with it. Like I said, ax squared plus bx plus c, a, b, c are your parameters. So like that, you have parameters. Now people, instead of talking about layers, nowadays just talk about how many parameters are there, right? So they don't even talk about how the layers are organized because it just doesn't make sense anymore, right? So we started from there, and all the things that you see on this slide, right, are all pre-ChatGPT. All these success stories that you're seeing on the slide are all pre-ChatGPT. Of course, some of these we're able to do better now with the transformer models that are available to us, right? But it's not that you need ChatGPT to solve all of these problems, including problems like solving math theorems that have been not proven for several decades before that. Right? So things like that. So I just like to show this slide, a couple of slides here. In 2014, so AlphaGo was the first computer program to defeat a human player, right? So this was such a big event for some sense with the AI community that we even made movies about it. This was in 2014. And in 2022, it's completely changed. What is newsworthy has changed. So the newspaper headlines say man beats machine at Go, not machine beats man, right? So it's no longer news if machines beat men, but other way around becomes big news, right? And so that's where we are at, right? But unfortunately, all of these are great, but there are some times when when we try to do this in real world, right? So for example, at least the science reporter should know that IBM Watson did not make a huge headway in real applications, right? So and then so they had to roll back, and likewise in many other cases, right? People had to actually step back. Okay? So that's with deep learning and where we are at, right? And let's get into generative AI. So this is a different way of thinking about the learning problem. Right? So the whole excitement with generative AI started with OpenAI, right? Because they introduced ChatGPT as we saw in Sam's tweet earlier, right? The reason for the excitement, in my opinion, is the unfamiliarity with the technology for the general public, right? They expose the general public to cutting edge AI. So far we have been consuming AI through some kind of a product, right? Whether it is Google Maps or whether it is Alexa or whether it's some kind of a medical bot, whatever, right? So we have been consuming AI through some kind of a product or some kind of an interface. But ChatGPT was literally like a raw interface to an AI directly. So you could ask the AI to do whatever you want, and it was trying to do it. Right? It's not like OpenAI was the only company with that technology at that point. It's just that they decided to take this risk of opening up the raw AI to interactions with the general public. I mean, their goal at that point probably was to get more data to see how what are the different ways in which people start using this such a powerful AI if it's available to them. But whatever it was, right? So it's been an extraordinary boost both to AI research and AI productivity and hype. And it is a very powerful tool. Not that it is omnipotent, it's not going to solve all problems, right? But it's a very powerful tool, right? And still, a lot of caveats exist because it is significantly, it's a generational change, right? The way that we are able to interact with AI systems now has changed very much, right? So we have to really think about what's the most responsible way of using this kind of power. Uh, so generative AI kind of started typically didn't start really with the LLMs, right? Didn't start really with ChatGPT. Generative AI started with all these image systems, right? So DALI and Stable Diffusion and Midjourney, all of these early versions of these certainly predate ChatGPT, and you could see that they were amazing at generating beautiful pictures, right? And so today we are in the era of LLMs. So this slide is slightly dated. I mean, I have to change this slide every so often. But so there is GPT-4, 4.0, and there is Llama 2 and Llama 3 now. Gemma 2 is there already. So many things, and there are a lot of excitement, right? So we passed the medical board exam, right? Law exam, and it's solving all kinds of theorems and proofs, and it's able to do multi-step reasoning, etc., etc. Of course, it's able to write programs, right? So that's another huge advantage you have with these models, right? And many of these models, both language and as well as multimodal models, are out there, and including models from India, right? Like Sarvam and Bharat GPT and so on and so forth, and Airavat. All these models are available now. So the field is getting very exciting, right? So this is where I wanted to do a little bit more on. Sorry, there is some scribbling that seems to be coming on my screen all the time. Apologies. So and so let's talk about a few terms here, right? So the first thing I want to introduce you to is the whole idea of what is this generative AI, right? So this is again back to school. So we talked about the usual machine learning, right? It's called supervised machine learning, so which I put it as usual AI because that's what people think of AI nowadays. So given these examples, right, the examples that you have here, given all these examples, you want to learn a rule that tells you, given a new data point, what is it, right? Sorry. Given a new picture, I need to tell you what it is. In this case, I would answer it's a dog. So what does generative AI want me to do? So I'll give you the same data, right? I'll give you all these examples, and then I'll tell you all these are airplanes, all these are automobiles, and so on and so forth. Now I'm going to ask you, hey, can you tell me what a dog looks like? As opposed to giving you a picture and asking you what it is, I'm going to ask you what does a dog look like, right? And then I expect it to generate a picture of a dog, right? So this is kind of roughly how generative AI works, and of course you can think of more complicated settings for this, but this is the basic idea. This is why it's called generative AI, because it generates the inputs for you, right? Not just gives you the label, right, of a given input. And the surprising thing is, generative AI in some form or the other has been around for at least 3 decades, if not longer, right? So there are some old statistical techniques which can be thought of as generative models, and they have been around for longer. But some form of AI that uses this kind of generative ideas has been around for at least 3 decades, and so it's not like the whole idea of generative AI is new, but what is new is some of the things that we have been doing with how we build these generative AI models, right? So the first next term that I want to think about is foundation model, right? So in some sense, I gave you the sense that generative AI uses the same data that supervised learning uses, but foundation model says no, you don't have to do that. You can basically do something like what's called as an unsupervised learning. So what do I mean by unsupervised learning? I don't give you a output. That I said all the pictures in the first line are airplanes, right? So I don't have to give you that. I just give you this large volumes of data, right? And the goal here is to learn how to reproduce the data itself. So if I give you like 10 airplanes, I want you to learn a function, right? That will give me something like an airplane later. And earlier we were learning a function that will give me a label, right? Give me a category. Now I want you to learn a function that will give me the input itself, right? And you put some all kinds of constraints on how big the function can be and so on and so forth. So it's not called unsupervised learning. Sometimes it's called self-supervised learning. And the big changes that came about were that we are now doing this on very large volumes of data. Literally, we're talking about internet scale data, right? And then complex, really complex model. We're talking about 100 layers and all that. Now, like I said, we don't even talk about layers anymore. We're talking about billions of parameters. They're not even millions, billions of parameters. So this essentially led to what are called foundation models, right? Which can basically whatever domain of data you train it on, right, it should be able to produce samples of data from that domain, even things that it hasn't seen before, right? Sometimes it just does it, sometimes you have to trigger it to do it, and so on and so forth. And but the complexity, right, introduced by these billions of parameters is actually allowing these models to do things which we didn't think were possible, right? But what is the underlying mechanism that these models operate on, right? So I'm going to use the large language models or LLMs as a example to show you how this happens, right? So LLMs are the foundation model for text, and it's kind of like the language model, large language model is a bit of a misnomer because it really has nothing to do with language, right? It can, like I said, it can be trained to predict any next token, right? The token happens to be a word, happens to come from language, then it becomes a language model. Or it could come from some unit of a image, right? Or it could come from some kind of a signal, right? ECG signal, right? It could happily predict all of these. And so it basically is a generalized token prediction model and happens to come from language, and we call it a language model, right? I put this word autoregressive in gray here because I'll explain to you what it is later, but almost all of these models are autoregressive models, and that leads to certain kinds of challenges, which is kind of being addressed by the O1 or O3 or whatever is the latest version they have released from OpenAI. Those models kind of address some of these issues, but it's still a huge challenge, right? So how do LLMs work? Right. So let's have a simple exercise. And unfortunately, I won't be able to query the audience. But let's start with this, right? So I watched a dash. If I ask you to fill in the dash, right? So somebody could say movie, or a play or a game or whatever, right? I watched a match, game, movie, play. All of these are potential answers each one of you could give. And if I ask you the same person, if I ask you a second time, you might give me a different answer, right? Let's modify this a little bit, right? Now I ask you this: in the new theater, I watched a dash. What would you say? There are again multiple answers, but you are less likely to say match or game, but you're more likely to say movie, and maybe you will say play because the play could be in a theater, right? But you're less likely to say match or a game, right? So what is happening here? How did you come up with these answers, right? So I started by asking, I watched her, and then you had a lot of answers to give. And then I say, in the new theater, I watched a dash. And then you had fewer options, but you still knew some answers, right? So how did you come up with these answers? Did you think about, what could be the possible settings and so on and so forth? Not really, right? So what happens is we humans subconsciously order things based on frequency. So I don't bring out a grammar table or Ren and Martin when I want to check which of these two sentences is correct, right? So obviously I watch the cricket match is more common, right, than match cricket watch I. Likewise, right, this is a very extreme example of you substituting frequency for grammar, but typically many of these completions, right? I watched the cricket match, right, is a more likely completion for that sentence than game or hop, right? But still, you could say I watched the cricket hop, and that's still a valid completion. But depending on how often you use it in your day-to-day language use, right? Then based on that, you would likely to prefer that over match. So that's the crux of how these language models operate. They're next token prediction models. You remember I was telling you they are next token prediction models. So I've given you a sequence of tokens. It's I watched a dash, and then you are basically generating what should be the next word there, right? So these are next token prediction, and like we humans tend to do this by just by our large history of interactions that we had with the world. How do these language models work? They basically go to the internet, right? They take huge piles of data that is there. In fact, the original data set that was used to train the early versions of GPT was actually called a pile, right? And so we don't even know what data they are training these newer models on because they're first they don't want to disclose it for competitive edge, and the second thing is they don't want to disclose it maybe because they are a little bit worried about uh, further lawsuits than what they have. So here is what I mean by autoregressive, right? So the input, like I watched her, right? So here I'm going to recite the first law was the question, and then dash dash dash, right? And then the model says first it generates the word right? Right? And then just look at this. Yeah, it first generates the word then it adds the word back to the input. Next, it generates the word robot. Then it takes the robot back and adds it to the input, and so on and so forth. So basically, it's feeding back the first token it predicts, it feeds it back to the input, and then predicts the next token, right? So this is the basic idea behind autoregressive. And the fact that there are multiple ways to continue something, right, like you saw here, right, the match, play, etc., etc. So like that there are multiple options for a LLM to continue what it says, and some it just chooses, like it tosses a coin, and then if it heads it'll say match, if it is tail it'll say play, right? Something roughly, right? So that makes it very random. So every time you go and ask the same question to an LLM, it could give a different answer because of this kind of a setting. So now that's the basic idea, right? Of course, there are ways to make this more efficient and so on and so forth. But when we say that LLM is doing amazing stuff, what it is really doing is setting up this, sequence of prompts and then sampling, like tossing coins and generating words from the huge pool of data that it has seen. The reason these things do so well is the volume of data that they have seen. And perhaps one can argue that that is what humans also do, right? Humans don't have a true understanding of what is going on. They're just generating something from the volumes of data. But we certainly are doing something more, right? We cannot remember everything like these machines can. Right? And of course, the same model that we talked about, autorecursive model, allows you to generate these kinds of full-blown essays. And in fact, a lot of things that we want to do, we want these models to do, can be thought of as this kind of a next token prediction, right? You want it to generate a summary of a big article. You can just feed the article. Now we can ask questions like, how would you rephrase that in a few words, right? Then it gives you a shorter version of it. Or you can give a review and then ask it, okay, on a scale of 1 to 5, okay, what is the sentiment of this review, right? Or you can have huge volumes of data, right? You can just feed in several pages of data, and then you can ask questions about, hey, can you tell me, what it is, and so on and so forth. And variety of things. I mean, of course, I mean, more than examples I can cook up here. Most of you have probably played around with these models, and you know what kind of questions to ask, right? Of course, you can do a lot more. So now it's a much more complicated prompt with includes images and things like that, and you can ask it, hey, look, there is something wrong. Can you fix the problem? And then it actually generates a response, including the right formatting, so that you can actually render it on the screen and see what is happening. And the same thing with all kinds of amazing queries that you can ask. But remember that at the end of it, it is still doing some kind of a prediction problem, right? I mean, there are different ways of doing this for images, but this is what it does, right? And now we have come to the stage where we have this kind of quote unquote a co-pilot model for a variety of things, right? So I call it like an augmenting intelligence, right? So you have a human who's trying to do something, and then you have an AI that is working with the human that is making it a lot easier for the human to do these tasks. Of course, the one that is named Copilot is the GitHub Copilot or the Microsoft's Copilot, which actually allows you to write code, right, much more efficiently. So you can have the AI operate as a shadow coder, or if it's a really common coding paradigm, common business case that you're solving, you could basically even write the AI to write, get the AI to write the code yourself by itself, right? And that can be in healthcare. Obviously, you can have a co-pilot that's helping doctors take notes, that's helping pharmacists find the right medicine, etc., etc. And in pharma, there's so much work that's being done on using these models as a way to, short circuit the amount of time needed to, generate promising candidates for doing laboratory trials. Right. Of course, customer support is an area where a lot of work that's being done with these kind of co-pilot models, right? And then there is even in things like creativity in design. So Beethoven, I mean, some of you might have heard of Beethoven, that actually allows people to write, better music, right, by interacting with an AI that's able to generate these things. Of course, even search today, right, is significantly changed. One example is Perplexity, which is kind of revolutionizing how people access information on the net right now, right? So a lot of things there. So let's step back. I know I'm running a little late, but I'm going to take another 10 minutes, right? So I'm going to take another 10 minutes to talk about some of the problems that we are having with these models, right? How good are these models? I just want to take first things. Of course, this is something which all of us hear quite a bit about: fairness, bias, etc. So these are all pre-language models, right? Pre Gen AI. Even now, these problems do exist, even in Gen AI models, as he'll show later. Right? This is an example from a tool called Compass, which is actually being used in some of the U.S. courts to decide on bail. And you can see that the girl was designated as a high risk for repeat offending, while the man was classified as low risk. And it turned out that the girl was actually low risk because she was just come in for some juvenile misdemeanors, and this guy was a seasoned criminal, and when he was released, he actually committed more thefts, right? The reason the model got this wrong was obviously because the girl was African American and the guy was white, and therefore it just went with the bias that was there in the data, right? And so there's huge bias. So then there's a lot of hue and cry about this, and people try. Then Compass was taken offline, and then they have tried to fix it, but not completely successful. And here is another example of Amazon running into trouble when they were trying to use. This is all old news, right? Nothing new, right? So this is all old news, but they don't use this tool anymore. But they didn't anticipate it in the beginning, right? So that's a problem. But it's not like these old models have this. This kind of have persisted into the Gen AI age as well. So here is an example. So remember the prompts, right? So if I change the race here, right, in the prompt, everything else is same, right? So if I say white person became belligerent and violent, then the model says sent to hospital, right? And if I say black person became belligerent and violent, it says sent to prison, right? So that's the kind of prediction it makes, right? People have been trying to fix this, right, by doing what are called alignment things, right? So they try to align it with human preferences. So here is an example. So the model actually, you ask it to generate which team won the ICC World Cup in 2011, and it generates all kinds of answers, right? Because it's just trying to, guess from the data it has seen already. So the 2011 was won by Argentina, Sri Lanka, India, and then it also says the 10th ICC World Cup was won by India, right? And then the humans come and say, no, no, that's not the right way to do it. You have to say 10th, India won the 2011 ICC World Cup is the best answer to this, right? Not the one that you have generated. And then you feed it back to the model, and then it supposedly gets better, right? So that's the idea. But what happens is sometimes these alignment things, right, can go out of monk, right? So you obviously have heard of Google Gemini, generating very racially diverse Nazis, right? So it basically had, um, black people and even had Asian people and Native American people show up as Nazis. And in fact, this guy actually did a small study and humorously said that it is embarrassingly hard to get Google Gemini to acknowledge that white people exist, because they kind of, over-tuned the model to actually become more diverse, and that became an issue. So again, where do you draw the line is a question, right? So they have tried, they kind of fixed it now, they rolled it back, but still sometimes you get issues. So people are talking about all this race and other stuff, right? There are more subtle kinds of biases that creep in, right? This is one example that we tried. We were trying to generate how images to show future of agriculture with AI in India and things like that. And then when I asked these some of these models to generate how an Indian farmer will be working in 2047, right? And it gave me a couple of tractors and it gave me an iPad in the hands of the Indian farmer, right? And there's nothing more fancy than that. And if I had the same thing set in the Western context, it looks a lot more, science fiction like. So there are a lot of these kinds of biases that are there which we don't know about, right? I'll come back to that in a bit. But of course, there's always this, we, especially in the popular perception also, we tend to think of bias as being bad, right? So that's the challenge, right? Any discriminative decision making will have bias, right? A loan decision is typically biased against people without collateral, right? So that doesn't mean that that bias is wrong, because that's the business model, right? So I can't be giving away loan to people if I don't know they're going to repay it, right? So what we're really saying when we say bias is bad is to avoid socially unacceptable bias. And this is going to become very tricky for us, okay? Because in India we have very different axes of what is socially acceptable, what is socially unacceptable, right? And again, application wise, this will vary and so on and so forth. There's a lot of work that needs to be done to completely understand this landscape for India, right? So the bias fairness landscape in India. Right? The next challenge that typically comes up with these AI models is one of robustness, right? So there are many ways in which these models can be brittle, right? And I'll just give you some examples. So here is a slightly older AI model, but just to illustrate this, right? So the image that you see there, the model is predicting that it is a school bus, right? So now there is this image. I've taken it. I added some, like white noise, right? Like you see on TV in the olden days. And now you see this image, and I asked the AI model, "What is this?" You would think it's going to answer school bus, but it says now it's an ostrich, because this noise has been crafted to cleverly fool the AI, right? So and then you could do the same thing, right? So here I've added some noise, and then it says it's a gibbon, and this dog now becomes an ostrich, and so on and so forth, right? It's just like this kind of adversarial attacks on these AI systems, right? They open up your whole solution to different kinds of attack vectors because of this kind of brittleness in the model. Of course, you can try to make sure that your AI system is robust to this kind of noise, but it's like literally like an arms race. So you make it better, then somebody else will come with a different way of attacking the model and so on and so forth. So you have to look at all ways in which you're going to achieve cybersecurity, right? So now people talk about really sensitive systems should have an air gap, and when they're talking about cybersecurity, things like that. So with AI also, you would need something along those lines, right? But this kind of brittleness is not necessarily due to attacks, right? It could be because the data has truly rare samples, right? So here is a image where the one on the left, right, this one is actually a normal eye, and the one on the right is actually a diseased eye, right? But for us, it's not going to be very clearly visible. And if you don't have enough samples in your data that are labeled as normal, so the AI is going to catch these images also as being abnormal, right? So because it doesn't see enough of these, right? So this kind of unseen data or unmodeled data error is also something that arises in these things. And likewise, I already showed you some of these examples where it was working very well in the laboratory settings, and when you actually take it out and try to deploy it in hospitals, some of these models failed. Right? There's another source of errors which many of you might have heard of, right? This is something called hallucination, right? So this factuality is a problem, right? One reason for the factuality being a problem in Gen AI systems is because of this notion of hallucination. So here is an example where when you query the early versions of ChatGPT on where do people smoke more on average in Russia, it gives you an answer, a lot of numbers and things, and every number in red is wrong according to the World Bank statistics. It just cook those numbers up. Right? And here is another example. This what is the most cited economics paper of all time? So if you go now and ask it, it'll give you a different answer. But sometime back, this was the answer it gave, and it's very detailed, right? It tells you who are the authors, where it appeared, what was the contribution, how many times it has been cited, and so on and so forth. But everything is made up, right? In fact, these two people have never written a paper together, even though both of them are famous economists. So what is happening, right? Can we fix this? The problem with hallucinations, yeah, like you saw in the simple example I was telling you earlier, right, where it said to 2011 World Cup was won by Argentina, right? It's trying to predict the next token somehow, right, based on the prompt that you have given to it. And because the prompt kind of sets up a fairly large scope for it to generate these tokens, it happily sample something. Okay, this guy's name has appeared a lot. Douglas North has appeared a lot in economics, right? So he has actually written very popular papers in economics. So if I ask you for a most cited paper, then the chance that you will generate Douglas North is very high, even though he has not written the most cited paper. So that's basically how these models operate, right? But this is a necessary evil. So hallucination is exactly the same mechanism by which the AI is giving you answers to questions it has not seen before. You think up of new questions and you ask the AI, and if it gives you an answer which is factually correct, you are happy. You call it the model is creative, right? It's knowledgeable. It gives you an answer that is factually incorrect, right? Then you call it hallucination. But the problem is the mechanism by which it operates is the same. So if you stop hallucination, then you will stop it from generating new things, right? So the hallucination is necessary evil, so you have to figure out how to do this. Okay? But hallucination is not the only source of factual error. In fact, misinformation also is a huge problem, right? Here is an example that came out a few weeks back or a few months back, right? So somebody is querying about cheese not sticking to pizza, and the Google's AI overview says something like you can also add 1/8 cup of non-toxic glue to the sauce to give it more tackiness. Basically asking you to add glue to the sauce so that it doesn't slip off the pizza. And this was not hallucination. Somebody had on Reddit actually posted a prank article that says that, oh, if you want sauce to stick, then you basically add some glue to it, right? And so because this is such a rare query, it picked that one document which talks about it, and then it generated that. So, and this is not just these kind of prank queries, right? There are a whole bunch of other misinformation that happens. Very popular misinformation. It could be misinformation about COVID. It could be misinformation about bullfighting, whatever, right? So various kinds of things which are very popularly in our mind, which we write a lot about on the internet, could also be fed by the AI as actual facts, right? So people are trying to fix this. So one thing that they have tried to look at, so very basic setting for what is called retrieval augmented generation, is where when somebody asks a question, you basically try to retrieve, potentially trusted background information, right? And then use that in order to generate your prompt. Right? So, for example, in something that we use when we had people ask questions about vaccination, but our domain from which it retrieves information is basically, textbooks on vaccination, recommendations, guidebooks, and so on and so forth. So things that doctors have written also, like case summaries doctors have written, and so forth. So, right, most likely the answer it gives you will be correct and not hallucinated or misinformation. So those are the kinds of ways in which you fix these. Robustness is again because of the model being so powerful, you can, and general purpose, right? So you can ask it to do things like repeat this word forever, and then it gives you all kinds of nonsensical outputs, right? And here is another example where somebody actually goes to a customer service bot in a car dealer's uh, website, right? And then they ask it to write a Python program, and it does, right? And of course, I'll skip this because we're running out of time. And of course, things like toxicity or issue, you might think that you have designed the model very well, but you can do things like role play, right? Instead of asking you to say something toxic, it's not able to. But then you ask it to play a role like somebody, then you say something, then it says. Nobody's going to stop me when I'm talking about deepfakes, right? So there are so many cases that have been out there, and use of fake images and mimicry is really not new, right? I mean, we don't have to blame AI for people being dishonest, but what AI does is it makes it easier for people to generate fakes, right? And that's any of these things, right? And the generative models are getting better and better at generating these fakes more things, and harder to distinguish true data from fakes. False positives is a big problem. What do we mean by that? You use models to figure out something is fake or not, and the model tells you something is fake, even though it is actually real, right? So much so that many of the universities which are using these models for figuring out what is fake have stopped using them because they are giving too many false positives, right? So here's another example where a study people conducted, so where 40% of people couldn't tell if a face is AI generated or not. Right? I mean, I'm not going to put that vote here, but that's something that how good they are, right? So really, I mean, fakes AI can generate all kinds of imagery, right? Right? It's literally like synthetic media. It creates media which is not true, but it becomes quote unquote a deep fake with the question of intent to misuse, right? So it's the blame should be on people who are taking these models and then they're misusing it. But also there are some subtle questions that we have to ask, right? So how was the AI able to generate these realistic images of real people? Because they were using images of real people to train, right? So did the models have the right to use it or not, right? So it's many hard questions that are posed by deepfakes, right? That brings us to kind of the societal impact of all of these AI technologies, deepfakes being one of them, right? So here is some questions about the ethics of building AI, right? This is something that happened a few, maybe a year or so back, right? Where, I have to disable annotation for people. Um, so they were basically people are being forced to work under toxic conditions, right? It is mentally taxing for them to label everything that is bad, even though we think it's good that the AI doesn't give you something that's toxic, pornography and things like that. But people who have to label something as this, right? They were suffering quite a bit. And of course, already the question I asked about are people allowed to use any data that is there on the web? And there is this question about journalists suing these AI systems, right? And of course, copyright violation or open source violation that's being caused by these AI tools, right? So it's going to have significant impact because it's an all-pervading technology, right? Jobs will have to be done in a different way. It's not like everybody's going to lose their job or anything, but people have to learn how to use AI to do their jobs, right? And security is going to become a huge issue in our society, right? Trust is going to become a problem, right? So how do you trust any communication you're receiving on the internet? Somebody calls you also, you're not sure how are you going to look at it, right? And yeah, so there is this question of erasure. I'll talk about that in the next slide. But there's also a question of environment in terms of impact, right? So these large language models could emit the equivalent carbon dioxide of 5 billion US cross-country flights in a year. This was a study last year, right? And of course, the cost is coming down of the individual operation, but then the scale at which you're operating also is going up. And for a country like India, where we want things to scale to billions of users, we really have to think about the impact, right? So this is what I call by cultural erasure, right? So if you ask the models to generate a typical house, right? This is the house it will generate, and that's not what Indian houses look like. But then you ask it to generate an Indian house, this is what it generates. And this looks like a cross between a temple and a house in a small town, right? Doesn't really look like a typical house that you live in, right? And likewise, if you ask it to generate an Indian person, okay, these pictures are from an Indian person. You can see that almost exclusively they are men, white bearded, wearing a pagadi, right? So that's the kind of diversity is going to show, right? Literally nothing, right? And likewise, if you ask it to generate an Indian woman, so it's almost always young, beautiful women, and wearing the head covering, and almost always in orange clothes. Right? So some of these, of course, there are different peculiarities to different models, but because India doesn't have enough data online, right? So these things can become a challenge, and of course we have to worry about fixing these, right? So the current status, right? So the kind of excitement that you had when ChatGPT came, right? That's kind of getting a little bit tempered now, right? That's because, like Arvind Narayan, who is a professor at Princeton, who says, so people underestimated the huge gap between proofs of concept. As soon as you had access to this powerful AI, you could just build all of these amazing proofs of concepts. But getting from there to reliable products, right, because of all these other subtle issues that we have been talking about, right, has been pretty hard. And so people are struggling with that. So that's why I've not had the market getting flooded with all these Gen AI products that we thought was going to happen. So things are slowing down a bit, right? And here is another study, right? It's a productivity boom of AI overhyped. So 96% of C-suite leaders expect AI to increase productivity, and but 47% of employees say they don't know how. That's because the first thing is they have not thought through, right? What are the ways in which AI can help, and they don't know if these the right AI tools are available for them, right? So a whole bunch of questions on that, right? So so basically it means that we have to train people better in order to use this AI so that they actually get the productivity that is promised from AI. Right? So this is my last slide. ChatGPT and its ilk are here to stay. I mean, there's no way we are getting rid of all of these AI things because they're amazingly powerful tools for doing a variety of things, right? But long way to go before we can have super intelligence or human intelligence. Like at least, I mean, the optimist in me would say at least a decade, but the realist in me will say further out, right? And AI is often only a fraction of the whole process. AI is not going to solve a problem for anybody, right? So if somebody says, "Oh, I'll just throw AI at it, I'll solve it," that's not going to happen. You need all the sensors, you need tools, you need actually IT infrastructure. If you say AI is going to solve agricultural problems for us, we need the IT infrastructure to reach to the agriculture, right? And the domain information we need is also important. All of this is going to take up more effort than actually building the AI. So when we keep saying that we want to build AI to solve problems, we have to worry about the entire infrastructure as well. And so Indian problems need Indian solutions. We have to do it here. Like nobody is going to do it for us. In fact, there are many nuances which people outside won't even understand, like some of the things that is starting up. A lot of work for us to do. And so, of course, like I said, you can't solve it in one person putting it. So we have at the Center for Responsible AI, which we have been running for about a year now. We do have a very cross-cutting collaborations, which we are trying to look at all of these some of these issues that I talked about in terms of AI, right? So I'll stop my presentation here, and I welcome all of you to visit our webpage, come visit our center. And I know we have little time left, maybe 20 minutes, but I'm happy to take questions.
Thank you very much, Professor. Can you hear me? This is Bhavani.
Yes, Pawari, I can.
Thank you. Thank you very much for that insightful session. I request the media to post your questions in the chat window, and I am going to read that out to the professor. We will take as many questions as possible now in these 20 minutes. Thereafter, whatever questions you have, you can either WhatsApp it to me or to Sairam, and we will get these answered offline by the professor thereafter as well. So, Professor, I'm going to read out the first question. This is from Dr. Subhashri Desikan, who is from the Shastra magazine. Her question is, given that some problems that AI solves are not solvable by human beings, how do you know the answer is actually correct? Is there a proof as in a mathematical theorem? And in that context, what are the questions a reporter should ask to verify that a claim is indeed real? Back to you, Professor.
Ah, I'm not sure that the AI has been asked to solve problems for which humans don't even can't even recognize what a solution will look like, right? I mean, you might not know how to solve it effectively, but we know what a solution looks like. Right? I mean, I'm not sure. Um, we have solved problems where we don't even know what the solution looks like. If that is the case, then it's hard for us to solve. I mean, suppose somebody is coming up with a new cure for cancer, well, if it cures cancer, yeah, sure, we know that it's done, right? So, likewise, if there's a new medicine, new drug, that targeted drug I'm discovering, right, which humans did not know how to do, with all these advances in AI, I'm able to solve this problem. I do know if the drug is effective or not by going through the usual approval process, trial process, and things like that. Right? So, so many of the problems that I mean, at least I'm not sure what else is Subhashri alluding to, but in such cases, we might not know how to solve the problem, but we have a mechanism by which we'll know if the problem is solved. Of course, there is another class of problems for which there is no real answer that exists. There's always only a trade-off, and so we have to look at it in the context of the problem that we are solving. If a good trade-off has been achieved. And so as long as it is in a domain in which solutions are available, like at least solutions can be evaluated, the question that you have to ask is, hey, what kind of testing process have you put the model through, right? Have you done some kind of field study? Have you what's the data set that you use to test the model, and what kind of performance metrics do you have? Those are some of the questions that you have to ask to know if the claim is well, almost always the claim is going to be exaggerated, so you can try to figure out what's the true extent of the contribution by asking these kinds of questions. Yeah.
Thank you. The second question is from Miss Urvashi from the Hindustan Times. She says, thanks for an informative presentation. I'd like to know if our increasing reliance on AI will lead to dumbing down. Another thing, there is a lot of talk about Sanskrit being suitable for programming. I'd like to know your thoughts on it. Back to you, Professor.
Well, so what is going to happen, right? So now there's over reliance on using tools like WhatsApp, and there's a lot of bunch of things that you do on the phone, right? Now, if you look at how somebody in my vintage or older, right? So we are not going to be that comfortable using a phone, but we will probably be able to look at remember some things and answer things based on our knowledge and things like that, right? But if I ask a kid, right, like a 15-year-old or a 16-year-old to answer questions now, they would do it probably faster than I can recall from my memory by looking it up on the web, right? See, the ultimate, if you think of intelligence as the capacity to solve problems, then I'm pretty sure these tools are making us more intelligent and not less so. If you talk about intelligence as, hey, you have been growing up with these tools, I'm going to take away all these tools and ask you to solve problems. Can you solve those problems now? Then obviously you're going to become dumber, right? I mean, there are so many things that our forefathers could have done, which we won't be able to do without electricity now. Or the kind of arithmetic that people were doing, a couple of generations ago, mental arithmetic people were doing a couple of generations ago, we don't do now because the calculators are there. But do we consider ourselves dumber than our forefathers who were able to do all this computation? Maybe we are. But it's just a way of looking at it. If you look at it as a capacity to problem solve, I believe these tools are going to make you better at it, uh, not worse. And I mean, there are people. I mean, there have been claims that have been made about the other part of the question, right? There have been claims that have been made about Sanskrit and so on and so forth. I'm not going to come down on either side of the debate, right? I mean, as long as people actually buckle down and build, tools that use Sanskrit for coding, right, and demonstrate that it is better, great, we'll use it, right? I mean, hypotheses are fine, but we need proof.
Thank you, Professor. The third question is from Nivedita. She hasn't given her media affiliation, but I'm guessing this is Miss Nivedita from PTI. Her question is, who do you think should be regulating the field, and does it really need any regulation at all? Back to you, Professor.
Ah, okay. So yes, it needs regulation, but from a application point of view, right? So there are two pieces to it, and a lot of the times the use that you put the AI system to, right, is something that needs to be regulated heavily. I mean, it could be in finance, it could be in healthcare, it could be in a variety of other domains, right, where there are already sectoral regulators that are existing, right? I mean, for example, advertising is again something that we regulate quite a bit. Healthcare we regulate a bunch of other industries, right? So so in such cases, if you are going to use AI in those domains, right, the AI use has to be covered under that regulation, right? There's no point in saying that there's a central AI authority and then there is another healthcare authority and things like that. So it's going to become a little tricky. And of course, the existing regulatory structures might not be sufficient to cover all the kinds of complexities that are introduced by AI, in which case we probably have to step back and look at what changes need to be done. But the primary application regulation should come from the domain. So having said that, there are a few issues that are a little bit up in the air, right? So this is to do with how we build these AI models, right? So what kind of data are we allowed to use, right? And what kind of guardrails that need to be there in this AI model? Is there something that we can, in a very generic sense, say that these models should satisfy, so on and so forth? And perhaps the IT Act can be modified to do some of that, and therefore it will come under the regulators who are implementing the IT Act and so on and so forth. To the question whether there should be a specific AI regulator, um, at this point, I don't think so. Right? And there are a few things also about AI regulation, because a lot of this AI development is happening at an international scale, right? So if you look at the entire tool chain of some of how this AI gets developed, it's going to touch multiple countries. So if you really want to put in draconian regulations, it's not clear how would we even enforce that, right? So there are all these questions to be taken into account. But ignoring that, putting that aside for the time being, so I believe regulations are needed, but most of it is covered under the sectoral setting, right? So we have had multiple examples of, AI misuse being taken to court, and the courts being able to adjudicate based on the existing laws and not needing new laws.
Thank you. The next question is from Ms. Kanika Khurana from Times Now Digital. How much of a misinformation is enough to trick AI? And what can be done by media to counter this? I think you answered B earlier, but you can answer the earlier one. Thank you. How much of a misinformation is enough to trick AI?
That is very contextual, right? So, for example, in this particular case of glue sticking, There's just one article, as far as we know, right? I mean, there could have been some kind of amplification done. The same article could have been repeated multiple places. They might have posted the same article. But it was literally people actually, when they did the forensics, they basically tracked it back to just that one article, right? So in some cases, very little because of the context in which the question was being asked, right? And in other cases, you know, it might not be that easy to trick because of the extent of information that's available. But having said that, quite often, right, many of these large companies that build these AI models do not rely just on the data that is there out on the internet, right, in terms of misinformation and so on and so forth. They actually build their own guardrails, their own, rules and other things as to what is feasible and what is not, and what is correct and what is legal and so on and so forth. And so those can actually lead to unexpected consequences, like we saw with the Google Nazi responses, right? So it's not just a question of misinformation that is there on the web, but also the way you set up the whole system. So there's no easy answer to that. And if your question was about ostriches and gibbons, right? That yeah, that is really up in the air, right? I mean, it depends on what model you are using. It's very, very mathematical there, so there's nothing we can do about it. So this is something that I actually, when I was talking to the Shakti Collective, right, the fact checkers that were operating uh, during the elections. So one of the things I was telling them, the good old-fashioned journalism is something that is very important nowadays, right? So just because a source, just because you get your hand on data, is not enough. You should do some checking on the source and do the usual verification and other things that you do before you actually take the story to the public. But it's all the more important for you to do now because of the ease with which fake information can be generated. But it's very hard to take the entire chain of facts. Right? So a little bit of, so it's really the press has a much bigger role to play to make sure that these kinds of misinformation that was produced by these AI models and amplified by human users are limited.
Thank you. Professor, the next one is an interesting question for many journalists, also for PR professionals like us. This is from Sangeeta Kandavel from The Hindu. Can you give us some examples of AI tools that can help journalists with data analysis and fact checking?
AI tools that can help with Google. So, uh, yeah, I mean, there are all these other, AI-powered search engines that are out there that you can use for querying all kinds of information, right? I mean, I would obviously recommend Perplexity .ai, and so that's been one of the very powerful tools that people are using, right? But then fact checking goes back to how much you trust the source, right? And I'm not sure that is a universal ground truth for this. So if I go and look for facts on X, I'll get a different set of facts. If I go and look for facts on Blue Sky, I'll get a different set of facts. If people don't know, Blue Sky is another open or quote unquote liberal Twitter-like platform started by the founder of Twitter, right? To so so what is ground truth? What are facts here, right? So it becomes a little tricky. So if you want to do actual fact checking, I mean, I would still say good old-fashioned search through sources and then trust I mean, only go for the sources that you trust, right? But I don't think there is a better answer than that. Maybe there is a business opportunity there.
Great. Thanks. Professor, I'm going to club three questions quickly, very similar ones. One is from Mr. Jitendra of the New Indian Express. How AI is going to impact newsroom reporting? Media is already under threat from big tech like X or FB. The other question, which is similar, is this is from Mr. Kuldeep Chauhan from Hindu Mail. Do you think that generative AI will replace human creativity or will it help humans to enhance it? Back to you, Professor.
Oh, I obviously think that it's going to help humans be more enhanced, right? In fact, I gave you an example of Beethoven, which we don't typically think of AI generated music as something being very pleasing to the ear. But what Beethoven does is it gives you a basic tune, right? It creates a basic tune which then the human interacts with, right? It is no, can you make this thing go a little faster? Can you use a different instrument there? I want a slightly different way in which ordering the notes here and so on and so forth. The human can give different kinds of feedback, and then the AI basically tries to fit all of that and produce better and better music. And in fact, even just few days back, I was talking to some amateur musicians who said that their productivity has gone up significantly once they started using some of these music generation tools, which the tool by itself is not going to produce something fantastic. It might get there maybe another 20, 30 years down the line, but right now it is something that is significantly enhancing human productivity. The same thing is true so there is all these examples of AI generating art in the style of X, Y, or Z, which look great to lay people like us, right? But if you actually take it to an AI expert, I mean, to an art expert, he's going to tell you, where was this departure from the style of that artist, right? So now he can work with this AI and actually produce a much, much better copy of the style of an artist than some of us who just say, oh, please generate this, right? So I think in terms of creativity, AI tools are going to enhance humans, and you really need the humans there, because without the humans, you're not going to get that no perfection and the spark that you would expect from true art. And the other question of how much pressure is news media going to be under, and I mean, it's not a question of AI per se. It's just the question of the way which people are consuming information has changed so much, right? And I don't have an easy answer to that, because it's not an AI problem. It's a social media problem, right? So the way people interact with social media is very different. I mean, even for me also, like, who's a little old school, but still I'm started getting most of my information from my Google feeds and my X feeds and things like that, right? So I don't think it's an AI issue, and it's a much larger social question that we have to ask uh, about this, right? I don't know how I can get people to come back to traditional media rooms to consume information.
Great. Thank you, Professor. Very similar question also from Ms. Sarita Rai from Bloomberg in Bangalore. Does the world's most populous country need to worry about jobs? Are jobs going to be displaced by AI, especially given millions of software coders?
Oh, so some jobs will change. I mean, let me take it back. All jobs will change, right? The way the job is being done is going to change significantly. Just like the introduction of computers, right? Everybody uses computers now, right? So now everybody is going to start using. And again, if you want, let's just take an example of a software. Everybody's using some kind of an office suite, right? Whether you're using Google products or using IBM's or Microsoft, everybody has to know some kind of an office suite, right? Word processor, Excel, PowerPoint, whatever, right? To even function nowadays. So like that, you're going to need to use AI tools to function, right? So every job is going to change. Right? There's no question about that, right? And you're going to become more efficient at doing your jobs. Maybe the job that was done by 100 people can potentially be done by 10 with the use of these AI tools, and that's going to basically increase your productivity. The number of things that you can do is going to go up. So if you say that, oh, but that would mean that IT engineers, I mean, one tenth of IT engineers are going to be needed, the others are going to go away. That's not really the case. Right? I mean, everybody is going to get slightly better at coding because of the availability of all these tools, and you basically take up more work that you can do. That's one part of it. The second part of it is there are so many niches in India, particularly. You asked the question in the context of India. There are so many niches in India that are basically unfilled. Right? That's just we need so many more, healthcare professionals. We need so many more teachers. Right? So every field that you think about, right, except IT professionals, we need more of them. Right? That is a joke. Right? We need more IT professionals as well, but not at the scale at which we need teachers and doctors. And what the AI tools are letting you going to do is to get people even without the 15 years of training that you need to become a doctor to be useful in the overall healthcare setup. Right? Not that they're going to become doctors, they're not going to start treating people, but they can facilitate better access to medical care by using these kind of AI augmented devices. Same thing with teaching, right? So we can get people to become better teachers because they're using these AI augmented devices. So there could be so many new kinds of jobs that will get created. And I can't predict what are all the jobs that are going to get created, because this technology will affect every sphere of activity. So there will be some amount of shake up, job displacement. I'm not going to say that nobody is going to lose their job because of AI, but you're more likely to lose your job because of somebody who knows how to use AI to do your job than AI itself. Right? But a lot
Thank
of
you.
jobs will be created as well for India.
Thank you, Professor. There are about 8 to 9 more questions, but you have time for two more, and then we can answer the others offline.
Yeah, sure. Two more. Yeah.
Okay. This is from Miss Sindhu Hariharan from the Business Line in Chennai. As someone working on data journalism, I'm often asked by people if I can just upload large data sets or documents in Chat GPT or any other tool and ask it to analyze the trends. Can I rely on the answer given the hallucination issues? Back to you, Professor.
Yep. So that is a challenge. See, but then the more context you give to the LLM, right? The more context you give, basically, like a lot of documents that you're going to upload, and then ask the LLM to limit its responses to what is there in the document. Right? But the thing is, you have to be very careful about how you prompt it, right? The more cleverly you prompt it, the less likely that is to be hallucination. But then it's almost impossible to completely avoid hallucination under all circumstances, right? So because these models are very general purpose models, so for you to build a model that is more trusted, you probably have to, narrow down the scope of that model's language generation. Only then the chances of it being not hallucinated goes up, right? If it's going to be a very general purpose model, if you're just going to take one of these GPT models that are there and then try to use it, there is a chance that there will be hallucination, but you can minimize it extensively by doing the right kind of prompting, right? So, but yeah, that takes some practice to evolve the right language needs. Right?
Thank you, Professor.
But for
Yeah.
don't trust anything it says numerically. Right? So numeric. So still till today, numericity is a problem, right? So if you give it some numbers and ask it to do some computation, it can still go off the rails, unless unless you allow it to call Wolfram Alpha or something, one of those external tools, and pass off the computation to that. The model by itself, right? If you don't have access to external tool use, model by itself is typically bad in terms of handling numbers. But they're
Thank you.
fixing it by allowing it to talk to other tools, right? So you should use that facility.
Thank you. Just two questions and clubbing together here, which is based on data. This is from Vidhatri Rao from the Indian Express. Professor had mentioned earlier that there's not enough Indian data on the internet, leading to biases. How do we improve Indian data collection, and how can India build its own LLMs? Is one question. The other one is from Rivit, independent journalist from Mumbai. I'm sorry if I pronounced your name incorrectly. The question is, are we running out of data to train models? The Indian context is different, of course, considering we have different data problem altogether. But is there an argument to be made to use synthetic data to train future models? So I'm just clubbing these two questions. Back to you, Professor.
Okay. You club the questions, but they require different answers, though.
Yeah.
So, the first thing, right? There are a lot of efforts that are happening, right, to kind of improve the quality and the volume of Indian data that's available. So in IIT Madras, we have AI for Bharat, and they have been doing a lot of work in not only gathering, samples of recordings and text from different Indian languages, but also cultural artifacts. I mean, they want people to talk about a specific local dish, and then they record about it, and so on and so forth. And the idea is to be able to use all of this data to train models that are specific to the Indian context, right? And so AI for Bharat is not the only organization. Even companies like Google and IIC are also working on building these kinds of data. There's Speculate India, and there are a few other companies like Karya and so on and so forth, which are in this space, right? So where the idea is to not just get any kind of data, but also try to capture these kind of cultural artifacts in the Indian sense, right? The government has launched this India AI mission, and one of the pillars of this India AI mission is to figure out, you know, what should India do to build its own LLM? Should it build an LLM from scratch, or should it, take some of the existing LLMs and train it with Indian data? And what kind of applications we should be focusing this for, and so on and so forth. It's a effort that needs huge investment, and so the government rightly is taking its time to make up its mind before deciding to invest on something or the other, right? And to answer the question from independent journalist,
Mr. Rivet.
Rivet,
Yeah,
or WIT. I don't
that's
know how
right.
to pronounce it. I would like to ask ChatGPT how to pronounce RWIT. Sorry. Right. We are in some sense, right? There have been claims that have been made by guys so Ilya, right? So Ilya is one of the founders of one of the original builders of ChatGPT, and so he has made a suggestion. He has actually made a statement recently, right, that we are running out of data to train on. So this kind of, the plain models, right, that we are building, right, these GPT-like models that we are building are going to kind of see a plateauing effect because of the lack of data to train on, and all the experiments that people have been doing with synthetic data seem to be hitting a plateau. But here in again in ITM, we find that using synthetic data is actually still giving us an improvement because of the lack of Indian data, right? So Indian language data, particularly, using synthetic data is actually still giving us performance improvement with the existing setup. But I do believe at some point we will hit a bottleneck on just the simple transformer architectures that we are just scaling up to trillions of parameters and hoping that we'll somehow get data, synthetic or otherwise, to train that. But actually, to dial back and start looking at different architectures that would potentially take advantage of. Not all data is equal in some sense, right? I mean, so we have all kinds of domain theories, right? We have textbooks that kind of distilled a lot of knowledge and then allow us to build abstractions and allow us to build theories on top of it, right? If that is a way that AI models can actually take advantage of this kind of distilled knowledge, right? And then use this like a knowledge infusion as opposed to just taking these as sequence of tokens, right? But thinking about how much we have actually already distilled into this sources of information, right? I think we can do better. Right? So running out of data might not be a bad thing because it might stop and make us think about what are the other architectures that we can use to push the boundary as opposed to just transformers. But the shorter answer is uh, some of the people who are working with these English language models seem to think they are hitting a limit on data, real data and synthetic data. We are not seeing that yet with Indian language. Perhaps it will happen.
Thank you, Professor. One last question because it's very specific, and then I'll give it back to you for closing remarks thereafter. As a journalist, how to check an image is AI generated or content is AI generated? This is from Mr. Jitendra of the New Indian Express, and all the others We've noted your questions. Keep sending it to us. We'll get it responded offline from the professor. Back to you, Professor. Thank you.
So there are certain signatures to watch out for, right? There's a lot of training and other things people are now giving for figuring out whether some image is fake or not, right? For example, many of the open models, right, the cheaper models have difficulty in rendering limbs like the fingers, right, and things like that, right, and also the lighting sometimes is a giveaway, the way the lighting is done and so on and so forth. But things are getting better and better day by day, right? So it's harder to tell them apart. So if you're so somebody is walking, right? So sometimes the legs don't quite match up, right? So basically the left and right leg exchange while you're walking. Looks very weird, but it might happen just for like a couple of frames in between, and then it'll go off, right? So these kinds of things, I mean, you have to watch out very carefully. I mean, there are a whole bunch of these glitches that are prevalent in many models that people have out there, right? And also, it turns out that there are some very specific, pixel level signatures that some of these models tend to insert, and people have actually built tools that can look for those signatures as well, right? Not signatures might not deliberately be entered, but they might be looking for those signatures as well. And of course, there is all this talk about asking people to insert watermarks and other things. But the challenge with these digital watermarks is that they are easily editable and removable, right? So if the watermark is there, then you know it is fake, generated by a tool. If the watermark is not there, then it doesn't mean that it is actually a true video, right? I mean, it's easy enough to edit it out. So those challenges are there, right? And there are a lot of tools that are out there that can detect deep fakes and things like that, but they work on very narrow circumstances, and many of them have a lot of false positives. What, like I already told you the example, right, in the talk. So these false positives means that if it detects something as fake, right, then there's a good chance it's not a fake, right? So, but in some sense, it's okay for us because it now reduces the burden on you. You don't have to check everything. You only check things that have been, generated as detected as fake, and then you go back and check whether it's truly fake or not. But then there are tools like Human Eyes now, which make it harder and harder for these deep fake checkers or fake checkers to see if it is AI generated or human generated, right? So, like I already said, right, it's like an arms race that's going on. So there is no foolproof way to do this. So, like I said, fact checking, going back to the source, and other things are the way to go. I'm sorry, there's no good answer for it yet. I think we still need a lot more work. Some of the bad AI can be detected, right? The really good ones, we still don't. We're still struggling.
Professor Ravindran, thank you very much for your time, and to all our guests in the call. It's a pleasure to have you join the call. So this is Sai Ram Radhakrishnan from IIT Madras Media Cell. I have just shared my question in the chat window. So any questions that have been unanswered or any more questions, please email it to me, and we will definitely get responses from Professor Ravindran and share it. So thank you once again. Very kind of all of you to join the call. Thank you.
Thank you, everyone, and I hope this helped.
Definitely, Professor. I think it was a great learning session. Definitely. Yes.
Thank you, everyone. So take care.
Thank you.